Hi, welcome to my channel Cloud with Girish. In this video, I'm going to show you how to build a serverless generative AI solution to create meeting action items from provided meeting transcript file via REST API, Lambda and AWS Bedrock service. Amazon Bedrock is fully managed service that offers choice of many foundation models like Anthropic Cloud, AI21 Jurassic 2, Stability AI, Amazon Titan, and others. I will use Amazon Title Foundation model and I will invoke it via Amazon Bedrock API. Many meetings, whiteboard architecture design sessions are essential part of software development. Meeting notes are get recorded either manually or via meeting tools. Also, many meeting tools provides a way to generate transcript file for these meetings. Generating action item from these notes and transcripts is oftentimes a time-consuming process. Generative AI solution can help increase productivity and save time by automating the generation of action items from the transcript file. Let's look at our business use case. There is a transcript available for a meeting held. Meeting action item need to be created based on the transcript. An automated solution is required to create action items. An automated solution will provide a repeatable way to create these action items. Increase in productivity as team members usually work on documenting these notes can focus on other tasks. I will be creating the Lambda function via infrastructure as code approach using AWS Serverless Application Framework and CloudFormation. However, you can create the Lambda function using the AWS console as well. Let's look at our architecture design. There is a user that's invoking the API using API gateway. In a request, prompt is being passed, which is a transcript file. It's getting feeded to Lambda function. Lambda function is written in Python Boto 3 and invoking the Bedrock API. Underneath foundation model is Amazon Titan, and logs are getting logged in CloudWatch. Let's look at the prereqs. Prereqs include familiarity with AWS console, transcript for the meetings held, knowledge of Python Boto 3, knowledge of AWS Lambda, and basic familiarity with generative AI and foundation model concepts. Let's get started. We're going to review the Bedrock service, we'll review the foundation models, we'll request model access, we'll review playgrounds provided by AWS, we'll review some key terms like temperature, top P, max token counts. We'll also review the AWS SAM template since I'm developing my Lambda function using the serverless framework. So we'll review Lambda function, which is written in Python Boto 3 library, and then I will build the function locally using AWS SAM. I will validate the function using invoking it locally, and then we'll deploy the function to AWS SAM. Once function is deployed, I can invoke the API endpoint and validate the GenAI model response using a prompt. I'll review the response, we'll review the CloudWatch log, and then we'll review the pricing. Like I stated before, I'm creating the function using the AWS serverless framework, but function can very well be written without the framework and can be deployed using AWS console. Let's look at the Bedrock service. Amazon Bedrock is fully managed service that offers choice of many foundation models like Anthropic Cloud, very popular model, AI21 Jurassic 2, Stability AI, another very popular image generative model, and then Amazon Titan that's developed by Amazon and few others. Since Bedrock is another serverless offering from Amazon, it allows integrating with popular foundation models and also allow to privately customize foundation model with your own data using the AWS tools without having to manage any infrastructure. Here are some of the models that's supported by Amazon Bedrock. So you have Anthropic, you got AI 21 Lab, Stable Diffusion is there, Amazon Titan, and few others. For this workshop, I will be using Amazon Titan for this workshop. Before model can be used, you need to request the access to the model. I'm requesting access to Titan model. Depending on which model you request the access for, it may take from few minutes to a few hours. For Amazon models, typically it takes few minutes to get access to the models. Let's look at the playgrounds. Playgrounds are provided by AWS. You can access them via AWS console. I'm using a playground here for the Titan, and I can pass a prompt. I'm passing a prompt to create a JSON for customer, and as you can see, I'm getting the desired response based on the data element I requested. Now for this workshop, I will not be using the playground, rather will use Bedrock API to provide prompt and then get the response. Let's review these key terms: temperature, top P, max token count. Temperature is a value of 0. It indicates less random generation. A value of 1 means more random generation. Top P, if value is less than 1, it will have less probable set of tokens. And max token count, this indicates max number of tokens to generate. Responses are not guaranteed to fill up to maximum desired length, though tokens are factored in the overall cost. Hence, it is worthwhile to pay attention to max token you want to use based on your specific business use case. Let's look at our AWS SAM template since I'm using the serverless framework. So as you can see, it's defining few resources. One of the key resources here is the Lambda function itself. And Lambda function has the environment variables. I'm providing model ID, the max token count, the temperature, the top P as an environment variable. Reason for that is because I want to have the flexibility of passing the model ID as well as the max token count and temperature and other value via the environment variable. So my token count is 1000. With next invoke, it provides me flexibility to change the value to 2000 or so on, and without changing my code. And then I have another resource which is defining an API endpoint and a resource path of action creator with a method that will be a post method. Let's look at our Lambda function itself. So if you can see, the Lambda function is checking for the post method, and if my request is not through a post, then a check will be done and a message will be returned that only post method is required. And then I will look for the prompt. Based on the prompt and the other variables, a prompt body will be built, which then I'm using along with the model ID to invoke the Bedrock API and getting the response. Once a response is received, I'm extracting the output and passing it back to API as a successful response. Next, I will build the function using the AWS SAM framework. The command for that is SAM build. So once function is successfully built, I can invoke it locally using the AWS local invoke command and make sure that I'm getting the desired value for my environment variable, and also like that my prompt is getting processed per the expected code that I have in the Python function. Once everything looks good, I can deploy the function using AWS SAM. Once I have my API endpoint, I can validate it using a tool of my choice. In this particular example, I'm using Postman to validate the endpoint. As you will see, my method here is a post method, and I'm passing in my request a prompt, which is a transcript text file. Once I hit send, I'm expecting it to return a list of action item based on the meeting transcript file. And as you can see, I'm getting the action items written by Bedrock API by using the underneath model of Amazon Titan. Let's validate it looking at our CloudWatch log as well. And as you can see, I have 3 distinctive action items which have been summarized from the meeting transcript by the Amazon Bedrock. And that show the power of generative AI solutions. I have these action items that I can take and share with the team. So with this workshop, a serverless generative AI solution to create meeting action items from transcript using AWS Bedrock, Lambda and API Gateway has been successfully completed. Python Boto 3 were used to invoke the Bedrock API with Amazon Titan model. As GenAI solutions continue to evolve, they are set to reshape traditional workflows and drive tangible benefit across industry. This workshop serves as a compelling example of the transformative power of AI technology in addressing real-world challenges and unlocking new opportunities for innovation. Hope you enjoy this tutorial. I'm working on some other interesting content on various AWS topics. These will be posted soon. Please don't forget to like and subscribe. Thanks for watching.